Hello dear students, so welcome back to online classes. That is Kcet Neet. In the previous year questions we are discussing from the aldehydes, ketones and carboxylic acids. I started in previous class only, that is aldehydes, ketones and carboxylic acids. I done that is 2014 questions what they given from aldehydes and ketones and carboxylic acids. They given that is 8 questions. The very important chapter it is for competitive exams, right? Must also focus, right? And now in this class we will start with that Kcet 2015, the previous year, that is Kcet 2015, which is 9th question. You have to see that the formation of cyanohydrin from a ketone is an example of the given. Which is a question is formation of cyanohydrin formation of cyanohydrin from a ketone is an example of which is right, and this is an example of which is a question is here. So what is the question is given? Formation of cyanohydrin from a ketone is an example of the given question, which is first option A is given nucleophilic addition reaction. Option B is given electrophilic substitution reaction. Electrophilic substitution reaction. Option C is nucleophilic substitution reaction. And option D is which is the given option D is here, which is electrophilic addition reaction. Electrophilic addition reaction. Right. So the formation of cyanohydrin from a ketone is an example of nucleophilic addition, electrophilic substitution, and electrophilic substitution. Actually, which is the answer is nucleophilic substitution, nucleophilic addition reaction. How we have to take here, which is first. Then once you see that cyanohydrin, either if you take the aldehyde or ketone, you have to take aldehyde or ketone, you have to take here aldehydes or ketones, which is undergo the nucleophilic addition, which is cyanohydrin is formed from the cyana is the nucleophile, which is a cyanohydrin. And this which is a minor charge is this 5 plus on the center and the oxygen. Then the cyanide is coming to attack here, which is then which forms the cyanohydrin, which is forms Cl, then O minus. Then which is the transfer of X plus, then getting the cyanohydrin is a mechanism, which is the Cl and OH form here. Cyanohydrin is formed. So cyanohydrin is a addition of nucleophilic reaction. Nucleophilic addition takes place. So Cl minus is nucleophile, and this nucleophile is attached to this either aldehyde or ketone, which is forms aldehyde cyanohydrin or ketone cyanohydrin, which forms. Right? And this is about it. So the formation of cyanohydrin from a ketone is an example of what is a nucleophilic addition example. Nucleophilic addition is example, right? And now we have to take the next question. Go with the question number 10. Question number 10. We have to see that in the 2015. Question number 10. Right. So what is the given here? Either form can be prepared from all except under the given question. Either form can be prepared from all except either form can be prepared. Either form can be prepared can be prepared from all except, and that is the question. One option A is given. Option A is given butane 2-one. Butane 2-one. Next option B is given acetophenone. 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 Option C is propane 2-ol. Propane 2-ol. Option D is propanol. Propane 1-ol. Propane 1-ol. Right. See the question. Iodoform can be prepared from all except here. Given the question. Iodoform test is given by the compounds must be having which is CH3CO group methyl ketone group irbekant ಹೇಳಿದ್ರು. First condition. The second condition must be also the having the compound is show that is CH3CHOH ether. Andre methyl group is attached to CHOH group ಇರಬೇಕು, ಇಲ್ಲಂದ್ರೆ CH3 group is attached to CO group ಇರಬೇಕು. ಈ ಕಂಡೀಷನ್ ಇದ್ರೆ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಕಂಪಲ್ಸರಿ ಆ ಕಾಂಪೌಂಡ್ಸ್ ಎಲ್ಲ ಐಡೋಫಾರ್ಮ್ ಟೆಸ್ಟ್ ಕೊಡ್ತಾರೆ. ಐಡೋಫಾರ್ಮ್ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು ಆ ಕಾಂಪೌಂಡ್ ಇಂದ. Right. But we have to take here butane CH3 CH2 C11O CH3 butane 2-1 ನೋಡಿ CH3CO group ilva aitala andre must and should what is happening there. The CH3 group of can oxidize by sodium hypohalite, gives halo form, gives iodoform when you take the sodium hypoiodide. That is, I told in the previous class only. That is right. So methyl ketones and aldehydes oxidized by sodium hypoiodide, which forms iodoform. Right. So having must be group CH3CO group or COCH3 group. Right. Illandre CH3CHOH group content irbekadre compound alli ನೋಡಿ ಆಯ್ತಲ್ವಾ COCH3 is there or not. So that's why which is forms iodoform here, which is forms. Right. So iodoform can be prepared by using the first option is possible. Next acetophenone you have to take here. Acetophenone, and this is called acetophenone. You see the acetophenone is there or not COCH3 group in that. COCH3 group is there, CH3 attached to CO group is there, and so that is which is option A and B also showing that which is iodoform formation. Next propane 2-ol, which is called propane 2-ol. Propane 2-ol. Nodi, and you have to take that CH3CHOH group is there or not, and this group CH3CHOH group is there. And in this third option, we also that is forms which is also forms that is iodoform prepared, right? But you have to take that CH3 and it is propane 1 or CH3 CH2 CH2OH, and in this there is no CH3 group attached to that CHOH, and which is attached to ethyl group to this attachment, right? In this system there is no methyl group is here. So methyl ketones and aldehydes which is can undergo the oxidation by sodium hypohalite. I think what sodium hypoiodide which gives iodoform, and in this we do not have it, which is so option which is so first option, second option is right according to the question, but which is option D is the right answer according to the question. So except one, which one, that is option D is do not give iodoform, which is right, and this is the answer. Next question number 11, you have to see that question number 11. So what they given, we discuss here. See that acetic acid is question number 11. So what is that here? Question number 11. In your serial material, that is serial number, acetic acid is treated with acetic acid. Acetic acid is treated with is a treated with acetic acid is treated with the calcium hydroxide CaOH twice and the product so obtained and the product so obtained is subjected to dry distillation. Subject to dry distillation. The final product is which is a question, right? Option A is given propanol. Option B is ethanol. Option C is ethanol aldehyde. Option D is propanone. Option D is what is that? Propanone, which is right. So propanone. See that acetic acid is treated with the calcium hydroxide and the product is obtained is subjected to dry distillation ಅಂದ್ರೆ acetic acid treat ಮಾಡುವಾಗ calcium hydroxide treat ಮಾಡುವಾಗ ಒಂದು ಕಾಂಪೌಂಡ್ ಬರ್ತಾ ಇದೆ ಆ ಕಾಂಪೌಂಡ್ ಮತ್ತೆ dry distillation ಮಾಡ್ತಾ ಇದ್ದಾರೆ dry distillation ಮಾಡಿದ್ಮೇಲೆ ನಿಮಗೆ ಬರೋ ಪ್ರಾಡಕ್ಟ್ ಏನು ಅಂತ the final product is that after the dry distillation of that product obtained when the reaction with acetic acid with calcium hydroxide, right? Then see that first you have to take the calcium hydroxide, then first take the acetic acid CH3COOH acetic acid which is treated with the calcium hydroxide CaOH twice, right? So and which is Ca plus 2, that's why and the two molecules of acetic acid which can be formed here and which is calcium, that is a CH3COO twice Ca, that is right, plus and which is forms CH3COO twice Ca, calcium acetate is formed. That calcium acetate which is that calcium acetate COOCH3, that calcium acetate, right, which on dry distillation which is so the calcium acetate which is a dry distillation which takes place, the elimination of calcium carbonate takes place here. The elimination of calcium carbonate, the remaining compound is called CH3COCH3 plus which is called COCH which is forms acetone is also called propanone, which also called propanone or propane duo is also right. Propanone which is forms a compound. Acetone is also called propanone, which is so option D is the right answer for this question. Option D is the right answer, that is 11th question, right? See that so acetic acid is treated with the calcium hydroxide gives calcium acetate. That calcium acetate on dry distillation which is gives acetone. The product is called propanone. In these four options the propanone is the right answer, which is called right. So next go to the question number 12. Distinguish test between methanoic acid and ethanoic acid is right. Once you see that you have to take here. Right. See that question first. What is the question is here? The distinguish test. The distinguish test between between methanoic acid and ethanoic acid. Ethanoic acid is the first A is a Tollens reagent. Tollens reagent is ammonium silver nitrate solution is also called Tollens reagent. And what Tollens test is given. And actually the answer is this one, which is next. The B is sodium bicarbonate test. Sodium bicarbonate test. Both methanoic and ethanoic acids both are treated with the sodium bicarbonate test. They are not possible to distinguish by using the sodium bicarbonate test. Right. Next, option C is given litmus test. Litmus is also can be used to test for carboxylic acids. That much only, not possible to distinguish methanoic and ethanoic acids. Next, option D is what is that? Esterification test. Esterification test. So, carboxylic acids are treated with alcohols which gives esters. Any carboxylic acid, methanoic acid, ethanoic acid, protanoic acid, and these three, option B and C and D, they are, which is sodium bicarbonate test and litmus test, esterification test, all they are doing for purpose of carboxylic acids. But not the Tollens test. Like methanoic acid, what is the formula? HCOOH is the methanoic acid, which is. But ethanoic acid, what is that? C2H5. Should take the methanoic acid CH3COOH, which is called. Right? In the case of this, like formaldehyde, HCHO, the active hydrogen is present to attach the carbon of that carboxylic acid and the aldehyde. See that H is attached to the COOH, H is attached to like the formaldehyde. Actually, aldehydes of hydrogen, which is readily give the test, what is it from here? Tollens test is here. So, like the aldehydes, the carboxylic acid, methanoic is also having the one of the hydrogen is here. And that hydrogen can be easily replaced with getting the carboxylate ion, COO minus ion. Then that CO minus ion indicates that. What purpose for use that Tollens test is used to distinguish between methanoic acid and ethanoic acid. But when you take the option B and option C and option D, you have to observe here. See, sodium bicarbonate test is used for methanoic acid and ethanoic acid. Both are carboxylic acids. If you take the litmus test, blue litmus converted into red litmus, red is converted into blue. And you have to get the litmus test here, just the carboxylic acid test. Both are carboxylic acid there also. Then esterification test, both esters, both carboxylic acids are gives esters on here. So that's why D, C, D, they are used for test for just carboxylic acids, but Tollens test is used to distinguish methanoic and ethanoic acid here, right? And which is the question number 12 is here. Next, go with that question number 13. You have to see that Kcet 2016, right? The previous year, that is Kcet 2016, what they given, and see that we discuss now. That is question number 13. Now read the question. Just the question is what they given here. So benzene carbaldehyde is reaction with concentrated NaOH solution to give the product A and B. Right? Benzene carbaldehyde, benzene carbaldehyde is reacted with concentrated NaOH solution to give the product A and B. Okay, right. The product A can be used as a food preservative, right? And the product B is an aromatic hydroxy compound where the OH group is linked to sp3 hybridized carbon next to benzene ring. Aromatic next to benzene ring. Full stop. The product A and B are respectively. See, once what are that A? See, what is given? Benzene carbaldehyde is this, which is called benzaldehyde, which is called benzene carbaldehyde and benzaldehyde. So when you take the two molecules of this, which is treated with the concentrated NaOH, concentrated alkali, concentrated NaOH. So this reaction is nothing but Kanizaros reaction. Canisterose reaction, aldehydes do not having alpha hydrogen. They undergo the Canisterose reaction. They undergo the self-oxidation and self-reduction, which is they undergo the disproportionation with the concentrated alkali, which is forms one compound is a sodium salt of carboxylic acid, another compound is alcohol is formed here. So when you take that, so according to the question, benzyl carbaldehyde is treated with the concentrated NaOH in Canisterose reaction. The one product is formed here, sodium salt of carboxylic acid, that is called sodium benzoate is formed. Sodium benzoate is used as a food preservative compound, and which is compound A is here, right? And compound B is formed benzyl alcohol, which is called benzyl alcohol. CH2OH is a benzyl alcohol. Benzyl alcohol is formed, right? So compound B is this, right? And read the question. What is here? Which is, see, benzene carbaldehyde is reacted with the concentrated NaOH, a solution to give the product A and B, right? The product A can be used as a food preservative. Sodium benzoate is, remember it, you know in the chemistry in everyday life, but actually EL syllabus and chemistry in everyday life illa. So sodium benzoate act as food preservative compound, which is right, and then which is the B is formed. The product B is an aromatic hydroxy compound. OH group containing compound where OH group is linked to sp3 hybridized. Carbon to the next aromatic ring. The product A and B are respectively, A is what sodium benzoate, B is for benzyl alcohol. So where is that answer? Which is phenyl methanol is there. Benzyl alcohol is also called phenyl methanol. So option B is the right answer. Sodium benzoate and phenyl methanol is also called benzyl alcohol. Is also called phenyl methanol. So option B is the right answer. Next, question number 14 we have to discuss now. Right. Question number 14. So what we are given here? And once you see that question number 14. Predict the product C. Predict the product C. In the following series of reactions. Right. So predict the following predict the product C in the following series of reaction. Option A is butane 2-1 is given. Option B is, which is CH3 CHOH C6H5. Right. Option C is CH3 CHOH C2H5. Then option D is CH3 twice COH C6H5. Right. And what is that? So out of the 4 products, which is the product is getting? The product. Predict the product C in the following series of reaction. Here at the first question note first. CH3 COOH, which is treated with the PCl5, and it gives A. A is treated with the C6H6 in the presence of anhydrous AlCl3. Like B is formed. B is treated with the Grignard reagent CH3MgBr. Right. And C is formed. What is the C here? This is a question. Listen. Right. The question number 14. Just want to observe. Product the predict C. First we have to treat with the, what is that? CH3, acetic acid is given. Acetic acid is treated with the PCl5 phosphorus pentachloride, then gives POCl, sorry, which is CH3, COCl is formed, which is called acetyl chloride is formed. Option, which is A is formed acetyl chloride, then which is treated with the C6H6 benzene, then in the presence of anhydrous AlCl3, and which is forms acetophenone is formed. Benzene is treated with the acetyl chloride, which is called acetophenone is formed. CH3CO, C6H5 is formed. Then which are treated with the Grignard reagent CH3MgBr, then which is gives the product is here C double bond O C single bond, then CH3 will come attached, and right, and this MgBr goes to attach here. Then it is OMgBr first, then CH3 we have already. Then which are hydrolysis H3O plus. The getting product is here COH, CH3, and then CH3, right, which is called. And where we have the product C here, right, which is the C product, and which is called the B product, right. So, listen this, acetic acid is treated with the phosphorus pentachloride gives acetyl chloride. Acetyl chloride is treated with the C6H6 benzene, which is forms acetophenone. Acetophenone is reaction with the methyl magnesium bromide, which is gives the product is C here. So you mix the four options, which is the CH3 twice. Once you see that CH3 twice COH, CH3 twice COH, then C6H5. That is option D is the right answer. Right? Next, the question Kcet 2017 questions what they given. How to see now that for the Kcet 2017. Right. Kcet 2017. So what they are there, which is the questions. So 15th question. Lower members of aliphatic carboxylic acids are soluble in water. This is due to the simplest answer. Up to 4 carbon atoms containing carboxylic acid, nothing but lower members like ethanoic acid, propanoic acid, butanoic acid. They are readily soluble in water due to the formation of hydrogen bond with water. That is answer. So hydrogen formation of hydrogen bond with water is the right answer, which is called option A. Lower members of aliphatic carboxylic acids are soluble in water. This is due to formation of hydrogen bond with the water. That is right. Next, question number 16. You have to see that just. Question number 16. Reduction of ketones. Reduction of ketones. Reduction of ketones cannot be carried. Cannot be carried. Carried out with which of the following, with which of the following reagents? Of the following reagents, the question, right? And option A is given. Option A is given hydrogen in presence of palladium. Hydrogen in presence of palladium in bisulfate and quinoline. That is. So hydrogen in palladium, that is palladium, and BaSO4 we also write, that is BaSO4 and quinoline, which is called BaSO4 quinoline. Quinoline hapten. Right. And this can be used to This is, we also write Lindlar's catalyst is called. The Lindlar's catalyst is used to here. In first phase you know that well already. That is, alkynes are converted into what is it? Directly. Alkynes are converted into alkenes, cis and trans, especially the cis alkenes is getting by, that is pelladized charcoal, which is undergoes reduction of what is it? Palladium plus BSO4. Illadre, Rosenthal reduction, benzoyl chloride C6H5COCl, which is benzoyl chloride is undergoes reduction in the presence of Lindlar's catalyst, gives benzaldehyde. But what they given, reduction of ketones cannot be carried out with the following here, which is, so benzoyl chloride, which is called benzoyl chloride COCl, which is acid halides, nothing but benzoyl chloride in the presence of palladium BaSO4 is also called Lindlar's catalyst, undergo the reduction, which is used to what is that benzaldehyde is formed here, which cannot be carried out. The ketone, the reduction of ketones cannot be carried out by using this. This is only answer, which is right. And see that palladium plus BaSO4 undergo benzoyl chloride, which is treated with the undergo reduction. The Lindlar's catalyst gives benzaldehyde. Not the ketone cannot be carried out with the following reagent. Reduction of ketones not possible with this here Lindlar's catalyst. It is possible that undergo reduction with the benzoyl halides, acid halides, and also the reduction of alkynes takes place to give the alkenes, cis alkenes. That is also right. So that only answer. Next option B and C you have to take remaining options you have to check here. See option B, what is the given? Option B is sodium borohydride NaBH4 or LiAlH4, which is right. So sodium borohydride or LiAlH4. See once, which is reduction of ketones or C double bond OR, which is right. Reduction of ketones. So LiAlH4, which is undergo reduction, which is gives secondary alcohol RCHOH, which is called secondary alcohol is formed, which is RCHOH. So undergo reduction with NaBH4, sodium borohydride and lithium aluminum hydride, the best reducing agents. LiAlH4 is the best, more expensive reagent that is, which is called. So it acts as ketones undergo reduction. Like you have to take the primary alcohols gives aldehydes. Aldehydes gives primary alcohols, ketones undergo reduction gives secondary alcohols. Right. Next, and zinc amalgam, the third option. Option C is zinc amalgam, ZnHg, and what is it now? Concentrated HCl, and which is seen in the especially aldehydes and ketones, just Clemmensen reduction it is. Clemmensen reduction is a Clemmensen reducing agent it is. So aldehydes and ketones must have should, which is undergo reduction in the presence of ZnHg and concentrated HCl, then which is forms alkane, which is forms plus H2O, right. Alkane is for hydrocarbon, right. Next option C is also, according to the question, is reduction of ketones. And aldehydes and ketones in option D is what is given here. Hydrazine N2H4, which is NH2 is also called hydrazine. NH2, hydrazine, and KOH in ethylene glycol. KOH in ethylene glycol. KOH in ethylene glycol, which is a Wolff-Kishner reduction. Wolff-Kishner reducing agent. That is first hydrazine after react ಆಗಿದ್ರೆ hydrazone form ಆಗುತ್ತೆ. First hydrazone form ಆಗುತ್ತೆ. C double bond NH2, which is forms. Then which is treated with the KOH and ethylene glycol. Treated with that ethylene glycol. called gives alkane. Gives alkane. That is. See that, and which is NaBH4, NaLH4, ZnHCl, NaCl, NH2, NH2 hydrogen, and Clemens reducing agent, which is Wolff-Kishner reducing agent, and NaBH4. So reduction of aldehydes and ketones gives alcohols here. So ketones are reduction of ketones are possible with that NaBH4, NaLH4, then ZnHC and NH2, NH2 hydrogen. With the option D, option C, option D, is it possible? It is possible reduction of ketones carried out. But H2 caloric Winter's catalyst is used to prepare, that is used to reduction of acid halides, acid chlorides used by aldehydes, which is right. And this is not here. Option A is not here. The next question. So go with that 17th one. What they given? Once you see that 17th question. Question number 17. In the following sequence of reactions, that is the reaction will write CH3Br, KCN. The reaction is what is that now? KCN. A is a product form. A is undergo the hydrolysis, gives the B, right? So B is treated with the LiAlHO4, H4, lithium aluminum hydride. C. The end product C is what here? The end product C is what? Option A is here, which is option A is given methane. Option C, option B is given ethyl alcohol. Ethyl alcohol. Option C is acetone. Option D is acetaldehyde. Acetaldehyde. Right. Option D is acetaldehyde. CH3Br, which is treated with KCl, gives A, and A is undergo product form. A is H2O plus, gives B, and B is reaction with the LiAlH4 gives C. The end product C is what here? Which is so first reaction you have to observe. CH3Br, which is treated with the KCl, gives CH3Cl. Right. Ethane nitrogen is formed. Ethane nitrogen hydrolysis. On hydrolysis, ethane nitrogen hydrolysis gives carboxylic acid, that is CH3COOH is formed. This CH3COOH undergo the reduction with LiAlHO4, right, which is gives C2H5OH is alcohol. CH3CH2OH is called ethyl alcohol, which is called option B is the right answer. Which is so ethyl alcohol is formed here. Ethyl alcohol is formed. The next term. The question number 18, you have to see that just. Question number 18, 2017 only, they given the question number 18. What they given here? Once you see that, just. So 18, the Kcet reaction is an example of auto-oxidation. 18th question is given. Kcet reaction is an example of auto-oxidation, the given question, which is. See, option A is, it is a typical reaction of aliphatic aldehyde. Option B is, it is a reaction answered by only aldehydes do not containing alpha hydrogen, right? And option C is, it is a reaction answered only by aromatic aldehydes. And option D is, it is a reaction answered by all aldehydes, right? And you know the well already. Aldehydes and ketones, especially the aldehydes in the Kcet reaction, aldehydes do not containing alpha hydrogen that can undergo the self-oxidation, auto-oxidation can undergo disproportionation with concentrated alkali, which is from sodium salt of carboxylic acids and alcohols. Right? And according to the question, Kcet reaction, option B is the right answer because it is a reaction answered by only aldehydes. And which aldehydes? Only aldehydes do not having alpha hydrogen. and that only they undergo in the carnivorous reaction, not all aldehydes. This right, which is option D is the right answer. Next, go to the question number 19. Question number 19 in 2018. Once you see that, just what is given. Right. The appropriate reagent that following transition is, which is the appropriate reagent that following transition is, which is, and this is the OH is given here. Right, the OH is given. Then the C double bond O, which is the ketonic group is given. Ketonic group. Right. Next, the product is formed here, which is the product is this. The ketones, which is can be the product is formed here, right? And the alkanes are given by that is the two reactions are one is Clemmensen reduction, another one is which is Wolff-Kishner reduction. One is right. Option A is here, which is option A is ZnHC HCl, which is a Clemmensen reduction, right? Option B is NH2 KOH ethylene glycol. So it is a Wolff-Kishner reducing agent, which is right. Next, option C is which is nickel in H2, that is just in the presence of nickel catalyst undergoes reduction at addition of hydrogen. Next, option D is here, which is the given NaBH4 sodium borohydride, which is right. So sodium borohydride is given, which is so sodium borohydride NaBH4. So out of these four, which is the best conversion to get the CO to just CH2, which is called alkane, here, and which is called ketone group. So, and this is a wrong method, first option. So first we have to eliminate the which one is the wrong options here. That is nickel is the reduction takes place is alkenes to alkanes. Alkynes to alkenes you have to get by using this especially. Undergo reduction also here only, that is right, and it is the best, not the best reagent. And even the sodium borohydride also, which is not best reagent, is here, right? So ketones do not give that what is that alkane here, and which is also the wrong option. Then out of these two here, especially the Wolff-Kishner reducing agent hydrazine, which is treated with the KOH, and the getting the product is must be there, which is alkane. The CO group, which is can be converted into just only the variation is this much only, which is the CO group is converted into alkane, that is CH2 here, right? So that's why. So ketones to converted into alkanes, they the best reagent you have to use the Wolff-Kishner reagent hydrazine and heated with the KOH ethylene glycol is the best route to get the CO to CH2 group, which is the answer. Right. Question number 20. Once you observe that question number 20, right? Question number 20. So what is it given? In the following reaction, the compound Z is, and in the following reaction, first reaction is given, that is a toluene CH3. CrO2 Cl2 bromine chloride in the presence of carbon disulfide CH2. Then X is formed. The HCl hydrolysis H3O plus, and which is Z is formed. So what is a Z is here? What is a Z here? Which is called Itard reaction. You know the well already. The normal named reaction it is right. Itard reaction. So when toluene is treated with toluene, is also called methyl benzene. Toluene undergo oxidation with the bromine chloride CrO2 Cl2 in the presence of carbon disulfide, which gives the chromium complex CHOCrO HCl2 twice, which is right, which is called chromium complex. And this chromium complex on hydrolysis H3O plus, an addition of water takes place here, which is so, and which is hydrolysis takes place gives directly, which is called the benzaldehyde is formed. Which is called the product is what is formed here? Benzaldehyde is the product is formed. Benzaldehyde, which is answer, right? So benzaldehyde is where we have that in the option B, we have the bench aldehyde in the 20th question, which is 2018, right now. And these are the few questions here, right? So 20 up to 20 we discuss now, right? So the remaining questions we have to discuss about in the next class, right now. Thank you. We'll see you in the next class. Thank you.